And then welcome to a brand new lesson. This is Hub Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at factorization using algebraic tiles. Have you been struggling with the abstract concept of factorization? Then this is for you. Without much ado, let's quickly look into it. So what is algebraic tiles? These are what we call the tiles. So they are just visual blocks that are used to represent algebraic terms. They are visual blocks, as you see here, that are used to represent algebraic terms. This box here, this one you see over here, is a large square that we use to represent x squared. You see, so just as the name would suggest, that is x squared. Now, this rectangular one here would stand for x, and then this small one here would then be a unit. So this is the same as this in terms of sides. That is x squared. And then this long one here, as I said, is for x. And then this over here is also just for 1. Now, the color difference should just tell you what is its cardinality, whether a negative or a positive one. So if it is red, then it is a negative x squared. If it is red, that is, if the rectangle is red, then that is a negative x. And then if it is very small red, that becomes a negative 1. Those are the representations of the algebraic tiles. The main aim of this type of solution is just to arrange the tiles into a rectangle, a very big rectangle, where the width and then the length of the rectangle would be the factors that you seek. That is the factors of the trinomial that you seek. What this method does is it connects geometry to algebra. You see, so by using squares, rectangles, and then the very, very small cube, you are able to see the link between what? Geometry and then algebra. And it makes quadratic equations very easy to understand. So the main idea behind all of this is if you have any quadratic expressions such as x squared plus bx and then plus c. At the end of the day, we factorize this quadratic expression into 2 brackets. And that is the length times the width. So the 2 brackets that we get as a result of our factorization is actually the length times the width of the square. So without much ado, let's pick some examples so we see how we use the tiles to solve for factorization. So for our first question we have here, it says we have to factorize using algebraic tiles x squared plus 5x plus 6. Now, how do we go about it? We have an x squared, and we know what square or what figure represents the x squared. So this here is the figure that represents our x squared. So I'm just coming to write it under it. This is my x squared. Then we also have 5x. Now we know the figure that also represents the 5x. So we pick 5 of those. So picking 5 of those is going to be 1, then 2, 3, and then 4, and finally 5. Then we have 6 plus 6. So the unit is what? Just one of the cubes, the very small one. And since it is positive, we are going to take the yellow one and not the red one. So 6 of them. 1, 2, 3, then we add 3 more. So making 6. So let me just write them under it. So these are x squared. This becomes our 5x. And this becomes our 6. Now, all we want to do is we want to rearrange this so that it takes a form of a rectangle. Rearrange these shapes you have here for it to take a form of a rectangle. How do we do that? Let me first of all clean these writings we have here, and then we see how best we can arrange for it to take a form of a rectangle. In this we have here, so this one is just a guide. Hence, I'll take my first one and then put it here nicely. And then the best way to get the shape is to arrange the units right here. So I'm going to put this here and then put the remaining also beside it nicely. So as you can see, I have arranged the 6 units. So this was our x squared. That is the yellow, the green was our x squared. And then this 6 units is the plus 6 we have here. Then we now have the 5 x's. So this is an x, 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 and then x. 1, 2, 3, 4, 5. Now we want to arrange them side by side to this so that it makes a perfect rectangle. I'll take my first one and then put it here. I'll also take this and put it here as well. Then for the remaining, I would like to actually make them vertical. So this way, then you pick one and bring it up here. You pick the other and also bring it up here. Then the final one is what you have here. We are going to put it up here as well. This fits into what? A rectangle. Now, how do we get our solution from just this figure? It is very, very nice, as you would see. So let me choose to magnify it so that you see it clearly. Now for our solution, we are going to pick the bars and see the ones that will fit here perfectly. So talking of the bars, I can put one of the blue ones over here, you see, just to find out how many x's are here. And also, I can put another one up here. Now you realize that there are more spaces. So with those spaces, let's fill them with the units. So we have 1 and then 2. Then up here we have 1, 2, and the last one being what? 3. So let's count what the length represents and then what the width also represents. For the length, we know 1 bar is an x. So we have an x, and then this becomes a positive 2. And as well, for the width, or for this side, we have an x, and this also represents a positive 3. So just with this, we have the solution to our factorization, and that is x plus 2 in one bracket, then in another bracket, we have x, then plus 3. This becomes the factorization of this quadratic expression. So basically, this is how we use the tiles work out factorization. Let's take some few more where we would see or encounter negative ones as well. So for this second example, we have x squared minus 5x plus 6. X squared minus 5x plus 6, and we are still using the algebraic tiles. So we know x squared will represent 1 cube, one big cube. So that is going to be what we have here. This is for the x squared. And then we want negative 5x. For this time around, the x we have here is negative. So we are picking the red rectangles. So that is going to be 5 of them. 1, 2, 3, and then you need 2 more of them, making 5. Then we need 6 of the units, 6 of them. So for 6 of them, have 1, then 2, and then a 3. Then we add 3 more, making 6. So the whole idea here is for us to arrange so that it fits as a rectangle. So I'm just going to take this first one, then align it right at the top. And then for the units, you make sure you align them also beside each other. The arrangement is up to you, but then this is one of the best way of arranging. You make sure you put the very big one at the corner, and then the units come right after it, and then you try and then fix the remaining beside as well. Now you can even choose to take these two, and then bring them here, and then this other way. That is also fine. At the end of the day, you just want to make sure you have your rectangle drawn. So I'll pick 3 of my x bars, negative x bars. Then I'm going to put them right here. So this is the first one. And I'll pick the second one and also put that here. And the last one to complete what we have here. Now this shape is still not a rectangle. So you are going to pick this and then fill it into the remaining spaces you have. For this first one, I'll bring that here, then just align it nicely. I'll take this and then also align it nicely. And with that, you'd see that you have your rectangle. Let me maximize so that you can see clearly. So this is what we have. What unit do we have for the width? And what unit do we also have for the length? The best way to do that is by picking the x bars and then aligning them here so that you can do your measurement. For this particular side, or if you want, you can even just count and tell. So for this particular side, we have how many? If we are to arrange in terms of the bars, it is 1, 2, 3, then 4, 5, 6, 7, 8, 9, 10. Let's count that again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that is 10x because it is positive. So just for visual representation, you pick just one of the bars and then bring that here. Then for this, we need 3 of the units, but not yellow, but then red, because the red represents the negatives. So we go for our red tiles and then put 3 here to correspond to what we have down here. Now we are left to the top. So how many bars can represent what we have up here? Take note, these are the green ones. So we need the green bars. So I'll then go for my rectangle and then put that here. And also go for 2 more units because that is going to be what we need over here. Now that we've been able to fill to get our rectangle, we then straightforward go to our solution. This here represents an x. There is x and then minus 3 over here. That is 1, 2, 3, minus 3. And then for what we have here, there is an x and then a minus 2. That is minus 1, giving us minus 2. Hence, x squared minus 5x plus 6 will then give us an x minus 3. That is for this side. So in a bracket, and then we have x over here minus 2 also in another bracket. So basically, this is how we use algebraic tiles to solve for factorization. There are other complex examples where you need to add and then subtract certain number of tiles to make it a perfect rectangle. We would end here. This video was just to give you a basic understanding. We'll do more where we look at more complex examples to enhance your understanding. I do hope this lesson was helpful, and if it was, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now.